This video is about inverse trigonometric functions. This time we're trying to do a little bit of a comparison. So we discussed that y equal to sine of x if we restrict it between x equal to negative pi half and pi half, and then find a mirror image of it over y equal to x, we get the graph of arc sine of x, and that's the graph. And so how's this, what is the interpretation of this? When you're computing y equal to sine of x, you're really putting in the input is going to be an angle you put in, and what you get out is a ratio, which is the sine. When you're using the arc sine input is going to be a ratio, and then output is going to be an angle. So it's the other way around of each other. Here, y equal to cosine of x, we discussed that to be able to invert this, we have to restrict it to domain between 0 and pi, and then find the mirror image over y equal to x to get the this picture. What does it mean again for cosine of x and arc cosine of x? Well, how do we compare them together, compare them with each other? And so with y equal to cosine of x, the input is going to be an angle, output is a ratio. Here with y equal to arc cosine of x, input is a ratio, output is an angle. For a tangent of x, again, restriction was that we have to have between x equal to pi half, which is the vertical asymptote, and x equal to negative pi half, restriction, so we can have a one-to-one function and find the inverse. And then inverse look like this, which is two horizontal asymptote, and that means that as the input, the ratio that we plug in as an input approaches the positive infinity, the angle that is the output is going to be pi half. So this one is y equal to arctan x. And again, this time around, just discussing the domain and range. Domain of the arc sine, negative 1 and 1 ratio, that's the output that sine gives it. And then range of it is going to be negative pi half and pi half. There is no vertical or horizontal asymptote, and it kind of ends. It's just a little piece over here. Arc cosine. Arc cosine is going to be domain again, negative 1 and 1. Range is between 0 to pi. For arctan, the domain is going to be negative infinity and infinity. Range is going to be not including, see, those are the horizontal asymptotes, negative pi half and pi half. And then horizontal asymptotes are y equal to negative pi half and y equal to pi half. For the first few examples, what I suggest is that assume and rename arc cosines or arc sine or arc tangent as theta, and then figure out all the other values for that theta, for all the other trigonometric values for that theta. So we kind of assign theta to the arc function, and then we figure out other values, other trigonometric values for that angle. So as we did with trig functions, we used two reference one of them was the reference angle method. One of them was the table, the reference angle table. The other one was the reference angle triangle. In here, we also use both of them. And this is the reference angle with the right triangles. So what was the story? The story was that if I have theta angle over here, and a right triangle over here, and the right angles over there, then the side facing the right angle is the hypotenuse, and then the other side facing theta is all opposite, and then the side that is next to theta beside the hypotenuse is going to be the adjacent. And then again, sine of theta was all over hypotenuse, cosine theta was adjacent over hypotenuse, and tan theta was opposite over adjacent. Now the discussion is, so we had agreed on the fact that what arc sine of x gives us back is going to be an angle, and that's the best way for at least the beginners is to name him something that is reserved for angles, and theta is something that is reserved for angles in mathematics. So we name him theta. The question is, can I find sine of arc sine of x? So this one is arc sine of x, and I want to figure out what sine of arc sine of x is. And according to what we discussed before, the sine is the inverse of arc sine, and they should be equal to x. But please pay attention to this part. Sine is only inverse of arc sine over the domain negative pi half and pi half. And the only reason this order works because the arc sine stays inside and tells us that the range of arc sine is going to be between negative pi half and pi half. So sine would be restricted to the domain that makes it an inverse for arc sine. So this is going to work. And we also discussed the other way around, that sometimes it doesn't work that way. Now, can I find other value or other trigonometric values for theta? That's the other question. I could find the sine of it, and it was x. Can I find the other ones? I can use it the similar triangle to whatever I want and figure out that if sine of x, sine of arc theta is, let's write this as theta. That is also important. So sine of theta is equal to x. Let's write it over here also. Sine theta is equal to x. Going back here, sine theta is equal to opposite over hypotenuse. Can I make this opposite to be x and the hypotenuse to be 1 and calculate all the other values? Yes, again, by the similar triangle properties, we can do that. Any triangle that I can find with that ratio is going to be similar to this triangle, and it would work. So that I just choose the easiest one possible by putting the denominator to be 1. And so the hypotenuse equal to 1, the side equal to x. If I want to find either cosine of theta or tangent of theta, I need to find the adjacent. And to find the adjacent, I need to use a Pythagorean theorem. Let's do it. So this adjacent, to power 2 plus x to power 2 is equal to 1. That gives me that the adjacent is 1 minus x squared. Adjacent to power 2 is 1 minus x squared. And adjacent is supposed to be square root of 1 minus x squared. And so now I can figure out for this theta, and that is a theta between 0 to pi half, I can figure out the cosine of that value. Cosine of theta, which is arcsine of x, is equal to the adjacent over hypotenuse. Now how about tangent? Tangent of theta. What is theta? Arcsine of x, I'm sorry. And so sine, tangent is going to be opposite over adjacent, so it will be x over square root of 1 minus x squared. I think you noticed that at some point I said we're thinking about theta between 0 and pi half. And that's the customary way of treating the reference, right? But the interesting part is that for the formula only, it doesn't, the reference and the angle in the other side, which would be in the negative part, from negative pi half to 0, will give you the same result. And let's check that. The first one, sine of the angle, is always x. That is done. Now, if theta is not between 0 and pi half, then theta has to be, it's an output of arcsine, so it has to be in the other. If theta is not in 0 and pi half, then theta is in negative pi half and 0. And interestingly, the cosine of all values between negative pi half and 0 are going to be positive. So I don't need to put a negative sign in here. I'm all done. If theta is between 0 and pi half, we saw that this is by the reference triangle. Now, what if theta is not in 0 and pi half? Theta has to be in negative pi half and 0 because theta is in the range of arcsine. Therefore, it has to be the tangent, and this is going to be the fourth quadrant. In fourth quadrant, tangent is a negative value. But if theta was in here, theta x would have been negative because x is the sine value for theta. And therefore, this entire thing becomes a negative value. So we all checked. So in this case, then, when you use the formulas, and these formulas give you both the value for the reference angle, and it gives you the value, so the values for the first quadrant, and give you for the other value that can happen for that arc function. So this is the beauty of that when you the range of arcsine is going to be here and here, and over here is part of the reference, and over here tangent has the same sign and cosine has the opposite sign, which is a positive value. Now, can we do the same thing for our cosine? Yes, we can do the same thing for our cosine. Again, when we start, cosine value for theta, our cosine is an angle. Cosine value, cosine restricted to the range of the arc cosine is going to be a one-to-one function. Therefore, it's the inverse of arc cosine, and it's going to be equal to x. Now, how about sine? So to find sine, I'm going to use the properties of the right triangle again. Right triangle. So this triangle is a right triangle with an angle theta. Theta is an angle whose cosine is x. That's something that is important to read. Over here, theta was an angle whose sine was x. Here, theta is an angle whose cosine is x. And so I can put that on the right triangle. So theta is a triangle, is an angle whose cosine is equal to x. What does that mean over here? Means that adjacent over hypotenuse is equal to x. This is adjacent. Make the easiest one, and that would be x for the adjacent and 1 for the hypotenuse. And for that triangle is the easiest one that we can use. Now, to find sine, I have to find opposite. Again, I have to use the Pythagorean theorem, and this time I will have opposite to power 2 plus x to power 2 equal to 1 to power 2. So opposite is 1 minus x squared. So square root of 1 minus x squared. How about tangent of arc cosine? Then this time it would be opposite over adjacent. Opposite is this, adjacent is x. And so these are all the values that we find from the reference triangle, from reference right triangle. Are these okay for all the values of arc cosine? What are the choices with arc cosine? Arc cosine, the range of arc cosine is between 0 and pi. Between 0 and pi half is covered by here. So if theta is in pi half and pi, then theta, then pi half and pi is the second quadrant, then sine of theta is positive, and tan of theta is negative. Cosine theta is negative. So going back in here, the first one, if theta is in the second quadrant, our cosine of our cosine still x. If theta is in second quadrant, then sine has to be positive, and that's okay. If theta is in the second quadrant, then tan has to be negative. Top is positive, and since cosine is negative, this is going to be negative. So this entire formula would work. Now let's try to do arctan. Again, theta this time is an angle whose tangent is x. So theta is an angle whose tangent is equal to x. Find the easiest triangle with that. That's opposite over adjacent should be x. First thing first, tan of arctan of x, again, tan over the range of arctan is going to be 1 to 1. Therefore, it's an inverse of arctan, so it would be x. Now, what would the cosine of arctan of x be? Cosine of arctan of x is 1 over the hypotenuse. What is the hypotenuse? Use Pythagorean theorem. And it would be hypotenuse is equal to 1 to power 2 plus x squared. So it would be 1 over square root of 1 plus x squared. What about sine of arctan of x? Sine would be x over the hypotenuse, which is x over square root of 1 plus x squared. Again, what are the choices? Arctan, the range of arctan is between between negative pi half and pi half. If we are not in the first quadrant, we are in the fourth quadrant. And in the fourth quadrant, cosine has to be positive, which this works, and sine has to be negative. That would be the same SIGN as tangent. Both of them are negative, and it works over here too. So the reference angle and the other quadrant work for all three of these, and that's the beauty of it. That's actually part of the reason that we choose the restriction over sine, cosine, and tangent to find the arc trigonometric functions. Now, using the same methods, how can I find cosine of arc sine of 5 over 13, for example? Now I'm looking at, let's say, inside function is arcsine. So I can either use these formulas, or I can, if I cannot memorize the formulas, I can always draw my own reference right triangle. If I was going to use the formula, I would use the cosine of arcsine, and so what is x? X is this, and so cosine of arcsine is square root of 1 minus 5 over 13 to power 2, which is 13 squared minus 1, it's going to be square root of 169 minus 25 divided by 169, and the entire thing is 12 over 13. And it's supposed to, according to that, it's supposed to be positive, and we are done. The other way of doing this is to draw your own right triangle. Here, I'm trying to say, let's erase this part. I'm trying to find a triangle with an angle theta such that the sine of angle theta, so theta is equal to arc sine of 5 over 13. Therefore, theta is an angle whose sine is 5 over 13. So sine of theta is 5 over 13. Now, let's draw the triangle that matches that. Sine is, this is theta, this is 5, this is 13. By the Pythagorean theorem, the other side would be 12. Therefore, cosine of theta, which is cosine of arc sine of 5 over 13, should be 12 divided by 13. So again, the same answer. Cosine of theta is equal to 12 over 13. How about this example? Sine of arctan of negative 5 over 12. So one way is to use the sine and cosine and tan of arctan over here. And sine of arctan of x is going to be equal to x over this square root. So I can use it this way. So it's going to be x, again, this is x, minus 5 divided by 12 divided by 1, square root of 1 plus 25 divided by 144, and I get negative 5 over 12 divided by 169 over 144. This is going to come out of the negative 5 over 12 is 13 over 12. These two simplify, I get negative 5 over 13. So that's the first method. Now, how do I do the other method using the right triangles? The right triangle method, I'm looking for theta. And what is theta? Theta is an angle whose tangent is negative 5 over 12. So tan theta is negative 5 over 12. Going back to the reference angle, I replace this by a positive number, and that would be 5 over 12. Using Pythagorean theorem, I find it 13 over here. Therefore, sine of theta is going to be 5 over 13, and I have to find if it's positive or negative, because tan theta was a negative value, and we're in the range of arctan. Tan theta only, arctan is supposed to happen in the fourth quadrant. Therefore, this has to be a negative value. And so we're done with this. We come back and with a few reference tables and comparison with the other method with the triangles.